Hey guys! In this video we are going to talk about where the formulas for arc length and sector area come from. So we are talking about arc length and sector area. So to remind us of our definitions that we learned last week, a sector is an area bounded by two radii. So it's just a slice of our pie. So if we think of our circle like this, something like that would be a sector. And we're going to talk today about how we could find the area of that sector, just like we can find the area of a rectangle or a square or a triangle. And then our arc is some part of the circumference of our circle. So if this is my circle, my arc would be something like between these 2 points. It could be that piece right there. And we want to figure out how long that is. Just like you can find the perimeter of the shape, you can find a portion of that perimeter as well. And to figure out where these formulas are coming from, we're actually going to derive them. So here I have a circle. I just traced something circular and cut it out. And the first thing that I want to do is I want to calculate the area of this circle. To do that, I'm first going to need to find the center so I can get my radius, because we know that the area of a circle, the formula for that is pi r squared. Then we also know that the circumference of a circle is, the circumference is either the diameter times pi or 2 pi r, because remember that 2r is the diameter. We're probably going to use this formula just because both of our formulas have a radius in them, and it's going to help us when we're trying to move between different values. So if I'm going to be able to find the area and circumference of this circle, I first need to find the center. An easy way to do that is if you just fold your circle. So I'm folding it in half. As long as I can make 2 diameters, so I folded it again, and when I open it up, where those folds intersect, that is going to be my center. So now that I have my circle and I just highlighted the radius, I can take a ruler or a tape measure and measure that radius. And for this, we're just going to estimate and say that it is approximately 3.5 inches. So let's say that our radius is 3.5 inches. So we can calculate our area. We know area is pi r squared, so it's going to be pi times 3.5 squared. And when I do that, I can use my calculator that I've got right here. I can do 3.5 squared times pi. You notice that I'm just using the pi button on the calculator. And we're going to get that the area is 38.48 square inches. We can do the same for circumference. It's going to be 2 pi times 3.5. So I'm going to do 2 pi times 3.5. And we're going to get that the circumference is 21.99 inches. Remember, circumference is just a length. That's why I do not have square units, whereas area should have square units because we're asking about how much space covers a surface. So now that we have our area and circumference, how could we calculate a portion of the circle? Well, let's think about one of the easiest sectors. What if I asked you to fold the circle in half, and we wanted to find the area of this right here. So I'm going to highlight this whole segment, and we wanted to find that sector. First off, we know that that sector is a semicircle. And our logic tells us that this semicircle is half of our total circle. So the area, I'm going to name this just sector 1, right? So the area of sector 1, well, I'm just going to take half of the area of the whole circle, because sector 1 is just half of my circle. So I could do half of 38.48 or half of pi times 3.5 squared. And if I take my calculator and do that, I'm going to do 1/2 times 38.48. We're going to get that that area is 19.24 square inches. And I could also do it from this formula. If I do the same thing, 1/2 times pi times 3.5 squared, I'm also going to get 19.24 because 38.48 is pi r squared. Now, could we calculate the arc length of this section? So if I just wanted to calculate the edge of our region, if I just wanted to calculate that edge, well, that's part of my circumference. And it's actually going to be half of our circumference because it's half of the circle. So I could say that the arc length of that section is just going to be half of the circumference. So I can do 1/2 of 21.99 inches. And if I take my calculator, 1/2 times 21.99 is 10.995, or that would round to 11. So now we found our arc length just by using it as a fraction of our circumference. Let's think of one more example to kind of confirm if this is going to continue to happen. What if I asked you to fold this circle into quarters, right? I asked you to fold it like this. Well, if I open it back up, that would just be one piece over here, it would look like. It would be like that section right there, and we could label that with A2. Well, how is this area going to compare to the area of the whole circle? Well, this should just be 1/4 of that area. So I could, for section 2, I could say that my area is going to be 1/4 the area of the circle. So I could do 1/4 of the 38.48. You might also notice we could do 1/2 of this piece because we have now taken our semicircle and taken half of it. And we could use our calculator to evaluate what that is. We could also get that our arc length is going to be 1/4 of the circumference. So that would be 1/4 of 21.99. So I hope that you see that there's a pattern here. When we're trying to find our arc length or our sector area, we're just trying to find out what portion of the arc or the area of the whole circle we have. So now let's think about how we can generalize this into a formula, because not every section that we get is going to be so easy as a semicircle or a quarter of a circle. What if I gave you this little sliver right here? Well, how much of our circle is that going to be? We know that a circle has 360 degrees, right? A circle is 360 degrees. Well, this might be X degrees. Maybe it's 10 degrees, and that's 10 degrees out of our entire 360. So X over 360 will tell us how much of the circle we have. It's going to tell us how much of the circle that we have. And once we know how much of the circle we have, we can multiply it by the area or the circumference of the entire circle to get our actual values. If we were to generalize this into a formula, we know that area is pi r squared. So our sector area, if we know that area, it's a part of the area, right? So area is going to be pi r squared. How do we find our part? We find our part by looking at how much out of 360 that we have. It's x over 360. And in this case, we'll just say that x is the measure of that central angle. So it's a measure of the central angle. Right? This is our central angle because the vertex is in the center. If we wanted to find our arc length, we would need a part of the circumference. So our part is x over 360. Our circumference is 2 pi r. And yes, we could simplify this a little bit, but we can just leave this as our formula. If you can find the circumference and just tell me how much of our circle that we have. And that is where the formulas for arc length and sector area come from. In the next video, I'm going to show you some examples where we actually calculate our arc length and our sector area.